Okay, so just confirm which device you're using. Yes, Lewis.
Others are using phones.
Yeah, just confirm. If you're using a phone, just say no. If you're using a computer, a laptop, just say, or a tab, something that can be able to install applications that run on a computer system. So if you're using a phone, a tab, and the rest, just say no. If you're using a computer, that is a laptop or a desktop, then I just say yes.
No.
So I'm missing a response from Mutuku, Nasike, and Muya. I'm also missing a response from Mudeni. I don't know if they joined the meeting and disappeared. I don't know if they joined the meeting and disappeared. There is a poll that is running that you're supposed to answer. I can say yes on the messages. There's a poll that was running. I don't know if you saw that. Okay, and I can see the okay. So there are people who did not see the poll anyway, but still responded. Okay. Yeah. So the reason why I wanted to know that information is so that I know going forward when you are programming, when we give some assignments or some task to be performed, are you able to program and share with me your screen and as I mark it real time? I think that's going to be very helpful for us. Okay, so going forward, if you give a quiz, you can program it so fast in your laptop and share with me the screen, and I'll be able to see and mark it real time so that we move on. Okay, but quite a number are using laptops. A few people. Anna is using a phone. Okay, so apart from a few people that are using phones, but those phones can also be able to install some basic compilers. Especially you can run that program or you can do your programming online. There are online compilers. You just Google and find what is relevant for your phone. Yes, so I think we can begin our today's lecture. So if you can't hear me well, you can, I'll prefer sound. You can do an audio or you can share your camera if you can't hear me very well. Because I'll minimize the charts so that my slide can be zoomed enough to allow me see exactly what we are talking about. Okay. So our unit is structured programming, and this is basically an introductory unit to programming. It's an entry point to computer programming. And I'm sure as students who are pursuing a technology line, you must have known how diverse things have changed. Okay, how diverse things have changed with new programming languages coming on board, new development areas coming on board, and all those new areas require different way of doing things. So many people, you'll hear them talk about Pascal, or you'll hear them talk about Python, you'll hear them talk about Java, and so on and so forth. The reason is because the way the technology has transformed, require different approach and different levels of programming. Okay, so we're going to look at a number of things, including what is a programming language, what is a program in itself, how do we write these particular programs, very, very important. Okay, which softwares do we use to write these particular programs? Okay, and where do these particular programs used? Okay, so you can see my slide. I hope so. You share the screen. You can see my slide. If you cannot see my slide, kindly no. So we are looking at what is a programming language. What is a programming language? Like the same way we speak different languages, there's maybe for those who speak English, there's the one for the American, there's the British one, and so on and so forth. Okay, there's the Kiswahili on the other end. When you come to our mother tongue, there's a myriad of languages that originate from different regions. Okay, that's the same thing that happens with the programming. So we have so many programming languages that we use for different things. But in essence, what we are saying is the same. If we are talking about developing an application to address student concerns, then people can come up with that application from different dimensions, different languages, different platforms, and so on. So that's the same reasoning that we have in programming as an area of expertise. So the slides there talk about a tool for instructing machines. Okay, when you write a program, if it is not the initial application, then you're writing a utility program to run different software, or you're writing a utility program to help the computer system, the mobile system, to operate more efficiently or to secure itself. So it's either you are developing an initial application or you're providing instructions to run different softwares. Then we have what we call programming domains. Now, I'll be pausing on my slides maybe to help those people who are taking short notes. So I'll be pausing on my slides for some minutes. We have programming domains. These are basically areas of applications. And each area will have preferred languages. Each area will have a preferred language. So all those are areas of applications. You can have scientific application, business application, where most of us are. In fact, as a country where we are, most of our development is within the business applications. Rarely do we go the scientific way, the AI way, or even system programming. We rarely go that direction. So most of our programming is within the business, within the scripting, and rarely special purpose languages. But most of our applications rotate within the business. We develop applications to help other softwares run. Okay, so you'll develop a school management system that is going to run on top of other applications. You develop maybe a point of sale system that's going to run on top of other applications to be able to achieve whatever that application is supposed to achieve. But now where the whole world is moving, the programming aspect is going beyond the business. In fact, the world needs more scientific applications, in artificial intelligence applications, more than the business was, because there are so many problems that require more creative thinking, more scientific approach, and so on and so forth. So like, for instance, you talk about the modeling, mathematical models. That's an area that is really taking shape, given that there's so much data that is present within the IoT world, the Internet of Things. So you really need to model those data in order to come up with decisions, in order to come up with conclusions, in order to predict the future, and so on. So that's an area of programming that is calling for more experts, so that the data that is being generated from the world can be utilized for future decisions and for planning purposes. So those are domains that you as a programmer, you as an upcoming programmer, you can try as much as possible to try and fit into one of the areas, or not one of the areas, or two or three, or all of them. It will be an advantage for you. And the languages that you require to venture into those particular areas, all of them exist. All of them do exist. Then there's the concept of types of languages, broadly from the perspective of computer generations. I'm sure you did that in your introduction to computers. We generally have two broader classification of programming languages. There's the machine language, and then there is the high-level language. Okay, so machine, basically, we refer to the bits, the zeros and ones in general, okay, or the binary. And then the high-level ones, we refer to slightly more of English-like, something that you as a person, you can be able to read and interpret. Though when you write your program and give it to somebody who has not learned programming, he'll not be able to understand exactly what you're doing. But now, for the professionals in that area, the written high-level language is readable to them. So that's why we call it high-level. It's close to human, but low-level specifically for the machine use. So the bits that we use. Now, and what used to happen before we could move to high-level language is that you had to program in bits. You had to do translations from what you as a person understands into the bits, like the mathematics that you used to do maybe last semester, transforming some binary number into decimal and transforming decimal numbers into binary. So that's how programming used to work. And you can appreciate that at that particular point, there are still programmers who could develop applications at that particular point. So programming world has evolved, and it's becoming easier and easier by the day. What is remaining is how critical are you in terms of how you think about the problem to be sorted out or to be solved. How creative are you? That's what's remaining. Otherwise, learning a programming language has become a little bit more easier, provided you have the effort and the resources required, which are so much online. You can access at any time. So it's about how you think about the problem to be sorted out. That's what will separate you from the other person. Otherwise, learning a programming language is quite easy, and more direct with the current trends and resources available on the internet. Okay. So I've just mentioned that why we as humans, we cannot use machine language. It's quite problematic and requires a lot of effort. Okay, so I've just mentioned that. So there are types of programming languages that exist within the market. And all these programming languages come from what we call a programming paradigm or a style. Okay. That's the same way we'll classify people speaking different languages into some category or regions. Okay. So the programming paradigms or programming styles will group several languages together, not because they're same, but because they are similar. They share one or two characteristics in the way they approach the programming process. So the three listed here, these three listed here share some kind of operations. The way their structure look like, the way their syntax look like, is a little bit, they are comparable. Okay, so that's why we group them in one category. So categories that are used to differentiate these programs include structured programming, what you're currently supposed to be learning. There's object-oriented programming. There's the web-based or scripting languages. There's visual programming, and so many other programming paradigms. So ours is structured programming. And which languages are under structured programming? Part of them are the three that you can be able to see from the slide there. Then there's the low level that I've mentioned, what the machine will better understand compared to us humans. So ours is high level, then for the machine is low level programming languages. So those languages that belongs to the machine can be understood from a different point of view. If you want to do, like for instance, microcontroller programming, PLCs, programmable logic controllers, then you can be able to understand why do we need the low-level programming languages. Because at that point, when you are doing PLCs, you are working with two states, on, off, or true or false states. And that's where the machine operates best. So assembly language is being mentioned again as part of the low-level language. You can just have a look at the description there. So there is that word being mentioned here. So there is that conversion process that is supposed to be taking place. And there's that point here. This point here. The complexity in using machine language in software. So we've mentioned that too, how complex it is to use machine language. Okay. So the advantages are also there. You can just go through them. For those who are taking show notes, can also do the same. And you'll connect better with this point here, point 1, having learned the functions of an operating system. Okay, how operating system interface for different programs to work or to function properly. Okay, I'm sure you know what BIOS are. Okay, so I've mentioned high-level languages in my explanation. So there are languages that will enable you as a programmer to write programs. So the question we'll answer is, how do we translate high level to machine? How do we translate high level to machine? So we have what we call compilers, or we have what we call interpreters. These are a special range of compiler of programs that will do that job of translation. So they are a set of specialized programs that will do that job of translation from one piece of code in HLL to a machine version. And we'll do the vice versa from machine version back to an HLL, because when the machine is communicating back the feedback to you as a programmer, it has to be in a language that you can be able to understand. Okay, so there is that conversion to the machine language and back to high level language. So the advantages there also for the high level. So this one we'll have a look at them. Data type and natural structures. Moya, what's the problem? You saying you're not yet done? What exactly do you mean? Moti Moya. What's the story? This one? This one? Now, how many can you hear? Can you hear me? I can see there's Elder Queen and Muya are not in a position to get the sound or to get the audio. I don't know exactly what the problem is on your end, and maybe how. Elder Queen, check. Can you speak? Check. Can you so that you speak so that I be able to get where exactly the issue is. Elder Queen, are you there? Not yet. Can you try and speak? That is if you joined using the microphone. If you joined for audio only, then you'll not be able to. But you can see the slides. You can see the slides, Elder Queen. Yeah, and sure you can see the slides. Meanwhile, you can refresh that page. Just press F5. Try and refresh the page. Okay. Now, so I was talking about moving from high level to machine and vice versa. So there is that translation process, and I'd mentioned a compiler, a very important piece of software in programming in the 20th century. It has changed how programs are being written, the level of difficulty that you can be able to go through to write a program. You realize this as you move forward, how easy programming has become because of those compilers. They've really revolutionized the programming process. Some of them have even shortened the process of programming. You don't need to program everything, okay? Some of them you just need to drag and drop objects. Then you program you write pieces of code for what we call the action, okay? So what should happen if that particular object is clicked? I'm sure you've interacted with the form, for instance. So when you are submitting details, maybe from a website, okay, you have a form there with name, with registration number, and so on and so forth. If you're working with a programming language that has an advanced compiler, then those particular objects within the form, we normally call them fields within the form. You don't need to program most of them. Just drag and drop, then program the action, okay? The action there in that particular form will be the submit process, submit button that is always on that particular form, okay? So that's the action. So that is what you want to program. The rest you just drag and drop. So you can see how easy the compilation process has really revolutionized the programming. So because our structured programming will pick on C language as the case study, then the compilers available for C language are so many, and most of them are open source. But of course, all of us, you know what comes with free things. So when they're open source, you expect a few issues here and there. You expect a few issues here and there as you use them, okay? So C language has several compilers. There's what we call Microsoft Visual Studio. That is from the Microsoft itself, Microsoft Visual Studio, C++, okay? So that is from Microsoft itself. We have code blocks. That is for compilation purposes. Code blocks, that is CODE BLOCK, block, code blocks. There is an open source compiler for C language that you can be able to download and use. There is dev C++, DEV C++. Dev C++. There's also another compiler that you can use to develop C programs. And most of these compilers will serve 2 or 3 languages. Like the one I've mentioned, they serve both C++ as a language, and they can also serve C as a language. So you can choose which language you are developing your programs in, and then select appropriately. Then we also have an interpreter that's perform the same thing as the compiler. So it's basically about translation, okay, from machine language to high level, and from high level to machine language. So compilers are very, very important in software development process, and they cut across all languages. Okay, I'm sure you've heard of NetBeans, you've heard of Eclipse for Java, you've heard of Microsoft Visual Studio. The same one we are talking about can serve VB programming, can serve VB.NET programming, okay, as well as serve C and C++ language, okay. So they are all those myriads of compilers that are there. If you want to learn, for instance, Python language for today, the first thing you have to look for is Python compiler, okay. That's what will help you be able to know, are you writing the right Python programs or not? Because a compiler has the ability to check your program. Is it error-free? Okay. Does your program have errors, bugs, and so on and so forth? Then it can report appropriately for you to be able to choose or to change. So it's a testing mechanism for programs that we'll be writing. It's a testing mechanism for programs that we'll be writing. So that's the process. There's the compilation process. So this process should be two-way round. It goes this side and it comes back. Then to our language of choice or our case study. So that's how programming languages operate. So that's the center of computer programming. Those languages are the center. So you go and check more information about programming languages. You realize that there are generations of programming languages. There's first gen, second gen, and so on and so forth. So there are generations. Basically, the historical perspective of programming languages. How did they come to exist? How did they come to exist? The reason for those generations is because each and every time, we'll need something new to address So we can proceed, yeah? There's a colleague of yours or a fellow student who is not able to log in. So he's the one who was trying to call me. Yeah, we can proceed. So I was saying that programming languages will evolve, and still they'll continue to evolve. They'll come in different shapes, and the ones that already exist will be improved to make it more better, and we'll move in that particular direction. We'll go back to long gone programming languages, bring them back on board, improve them, and so on and so forth. So you, at your own time, go and check the generations of different programming languages. And of course, you realize the improvements that have been made from one language to the other, from one language to the other. So our case study is going to be C language, as I mentioned earlier. And we are going to use it to explore what programming is all about, how programs are written, how thoughtful process is taken into consideration to write a program, and so on and so forth. So the features are in there. What C language is able to offer. The major component of C that is associated with a structured programming style or paradigm is the ability to offer a top-down approach, okay, where we analyze problems from top to bottom in a very structured manner. And that's why it's used as an introductory language to the programming world, because it's more structured. It has most very well structured steps that anybody joining programming can be able to follow through and understand what are we really talking about. And then it offers basic programs to be written, and you can be able to use them for learning processes. You realize that very rarely do you come across an application developed in C. Okay, very rarely do you come across such kind of a program. The reason is most of the users who C language are in the scientific world, are in the system software's world, developing of operating systems, developing of huge applications. Okay, so if you check online what C language has been used in to generate, then you realize that they are very powerful programs or applications, some of them including operating systems have been developed from this particular language. But now the brighter future, or the better part of it is that we can use the minimum to explain how programming is being done. The introductory part of C to explain how programming is being done. That will help you get a good foundation moving forward as you try and now venture into other languages that may be of interest to you. Okay, so that's why C language and Pascal at some point is preferred for introductory purposes, so that you can be able to learn the basics of what programming is all about. So those are the features of C language. They are explained further there. So there's portability, and portability came about as a result of more compilers coming out. Okay, we are talking about the ability of a program in C to run in a Windows environment, to run in a Linux environment, and all different operating systems. That's what portability is all about. How portable is the program? Okay, so that came about as a result of different compilers being released into the market. Okay, initially C language was purely developed for Linux users. Okay, I'm sure at this particular point we know the difference between Unix and Linux, or how they relate together. Okay, so it was probably it was initially developed for those users, but now going into the market and trying to make the language more popular, then additional compilers have been released into the market, and currently C language can be used in different operating system platforms. Okay, so we are talking about library files, rich library files. You'll be able to see that when we write our first program. Several files that are available in C language. These library files, one, they make your work easier. Okay, one of the library files that you will mention at some point is called math.h, math for mathematics. Okay, this library file helps you compute mathematical functions. If you want to get square root of a number, if you want to get the cube root of a number, logs of a number, okay, you can be able to use the library to help you do that. So that's why we say, likewise to other languages, C language is a very powerful language as far as library files are concerned. Easy to extend, modularity, powerful operators and types, and of course fast and efficient. So all those are advantages or features that make C language a very competitive language, a very easy language to learn for programming beginners. Okay. Then the structure of a C programs. These are all what makes up a C program. The processor commands, functions, variables, statements, expressions, comments, and so many others that will come on board. These are just the primary elements, the primary content that you'll need to develop a skeleton structure of what C program would look like. Okay. So preprocessor commands, these are basically lines that would instruct the compiler on what to do before the compilation process begins. Before the interpretation of each line of your program begins, then preprocessor commands, also known as preprocessor directives, will instruct the compiler, do the following. Most of the preprocessor commands will always instruct the compiler to include library files into that program, so that we can be able to know whether your program contains errors or bugs, whether your program is correct, whether your program has utilized the right functions and expressions, and whether your programs has fully subscribed to what we call the syntax of a language, syntax of a language. Okay, syntax of a language. That's the rule. Okay, if you are being taught English, then you must know verbs, you must know prepositions, you must know all those dimensions of what an English language requires of you. Okay, if you speak English and you place an is where we are supposed to have a was, then that's an error. That's not proper English line. That's the same thing that happens here. So in each language, there's that syntax that we have to follow, that structure, that format that we have to follow. So if we say in C language, if you're writing your preprocessor directive beginning with a hash, okay, beginning with a hash, then that's a syntax of C language. That must be followed. Otherwise, you'll get what we call an error. We'll mention types of errors as we move forward, as we write some of the programs there. Okay, so syntax of a language has to be followed. If we say functions in C take this format, that format has to be followed. You go out of that, you get an error because you did not follow what we call the syntax of the language. Okay, so preprocessor commands are supposed to help us do that. They import library files that will subject our program to a check. Has it followed the syntax of this particular language, and so on and so forth. Functions are used basically to perform different tasks. We have input functions, we have output functions, okay? We have mathematical functions, and so on and so forth. So basically a function will be able to help us perform a given task. We'll handle input and output functions in our introductory part of writing programs. Those are the two types of functions we're going to deal with in our introduction part, okay? Then variables, these are memory locations. In fact, the best definition should be temporary memory locations. So variables are temporary memory locations. In your electronics class, for those who attended electronic class, you must have learned use of transistors, okay, for storage purposes. The ability of a transistor to move from on state to off state allows it to be used in the memory of a computer for storage purposes. Okay? So those particular storage locations is what we call the memory, the variables. Okay? So they are temporary memory locations. We'll use them to store our computational data, and when we don't want those data, we'll delete them. So that's why we say they are temporary. Then statements and expressions. Statements and expressions. These are basically what your program is all about. There'll be thousands of them if your program is a big application, okay? Because they express, or they'll be able to show each and everything that your application is trying to achieve. If you're trying to develop a student management system, then you'll have to see how student marks will be entered into that system, how the marks will be translated into grades, how the grades will be translated into a transcript, and how the student semester results will be computed together to give a graduation class, okay? Pass, first class, credit, and so on and so forth, okay? So those statements must be expressed within your program. Those are what we call statements. Then comments. Comments are basically explanation on what this program is all about, okay? They are not even important in the program execution. A compiler is not interested in the comments you've written in your program. Those comments are meant for any other person who would love to work with that program, or you yourself, if you're doing debugging, you'd love to know each line, what was supposed to be the action, what was the function of each line. You can only know that using a comment, because if you're writing a program with 1,000 lines, then it will be very difficult for you to cram what each line was supposed to be doing. So those very important lines, you can put a comment. This line is supposed to be converting student grades to scores, or converting student marks to a transcript, so that you know if the transcript has an error, just run to that piece of block or piece of statement, change it, give it the right formulation, so that the error can be well taken care of. Okay, so comments are not relevant in program execution. If you get an error, don't try changing your comments. Those comments are not even interpreted by the compiler. They are meant to help you debug your program and allow other people also to help you maintain your application, because they'll be able to read them and know what each line in that particular program was supposed to be doing. Okay, so that's the skeleton structure of a C program. That's a skeleton structure of a C program. That's how we'll write our programs. Preprocessor commands, a few functions, variables, statements and expressions, and comments, that is if you like. But it's good programming practice always to comment your program. Give comments to show exactly what you're doing. Especially even if you are, because of this type of learning we are pursuing, if you are submitting to me your work, okay, then the program you've written, if it is not executed, you will have to give it comments, so that I'll be able to know if my question was supposed to be a program to run an ATM machine, then you must show me this line is supposed to confirm balance. This line is supposed to check the PIN. This line is supposed to check or dispense the cash. Then I'll be able to verify that from if it is really doing what it's supposed to be doing. So comments are very helpful, especially if you are not in close contact. You are working with somebody elsewhere. Okay, so that's the structure of a C program. That's the structure of a C program. The sample is there. The sample is there. This is a preprocessor command or preprocessor directive. All of this. Okay. This one here is the directive. Okay. Hash include. Include from the English perspective. Bring on board. Okay. Bring on board. Include. So almost all preprocessor directives, almost 95 or 98, will begin with this symbol here, the hash. They'll not have the include, all of them, but most of them will have the hash. Okay, so what this line is telling the compiler is that if the execution process is going to be done, before it happens, before the program body is executed, this one here, bring on board this library file, include this library file here. This library file stands for, STD stands for standard. I is input, O is output, and H is header. So standard input output header file. What does it mean? This file here is responsible for verifying input output functions. Have you followed the syntax required by C language? as far as input-output functions are concerned. Have you followed that particular syntax? Okay, so that's one of the library files we are talking about. So once it is brought into the program execution, then the execution of the program body can begin. A question you might ask yourself, where are these library files? These library files come inbuilt with the specific compilers. So if the compiler is for C language, it will come with all the C language libraries as part of it. Okay, so when you include them, they'll be imported or they'll be picked from the libraries folder within the compiler itself. Okay, so a similar word for include that is used maybe in a different language like Java is import. Okay, so import or uses. Okay, uses is a keyword, is a word used in Pascal as a language. Okay, so uses, import, include, those are the words that quite often we use to represent the preprocessor directives. Then the next line is basically the body of the C language. What is missing in this program is we don't have variables. Okay, we don't have variables. We have statement, though we don't have expressions. Our comment is here. My first program in C. And you can see that comment there, there's a structure, there's a syntax on how it should be represented. You begin on the left with a forward slash, the asterisk sign. Put your comment, my first program in C. Close with an asterisk sign and a forward slash. So meaning, if you're writing a comment in C program, it has to be within that structure, within that block. On the left is a forward slash with an asterisk. On the right is a forward slash with an asterisk sign. Okay, so that's the syntax of writing a comment in C program. Okay, then the next line here, this one here, is an output function in C language, printf. What it does, displays information to an output device, whether it is a screen, it is a speaker, whichever type of output device. But the bottom line is this statement displays the output to an output device. Printf. And the syntax is, this is written as 1. So anything to do with display, you go for printf. That's the output function in C language. That's the output function in C language. Then back to line 2, which I did not talk about. This one here. Let me just do that. This one here, we call it the main function, the primary function, the parent function in C language. What happens is that all other functions that we write in C will only execute under this. So this is the parent function. Part of the reason why it is there, it's supposed to give us the feedback of the execution. Did we have an error in the execution process? Okay. Did we have an error in the execution process? Yes or no? If there was an error, this statement here will return the number of errors and the probable locations where those errors are, and probably the description why the errors occurred. When you write our first program, you'll see the description. The description can only be understood by somebody who is doing programming, okay? So if this parent function executed properly, this statement here, return 0, will return 0, okay? Will return 0. If the execution was not correct, there are errors, this statement here will not return 0. It will return 2 errors, 10 errors, 20 errors, 30 errors, or so on and so forth. Okay? So that's why we have this statement here, return 0. Okay? Return 0. So it will return 0 if and only if the execution was perfect. It will return 1, 2, 3, 4, 5, 6, etc. if the execution was not perfect. Okay? There is 2 very important symbols here. This one and this one. Those symbols, you can see them from your keyboard. They are called curly braces. C-U-R-L-Y. Okay? Curly braces. Brace is B-R-A-C-E-S. They are supposed to be used to enclose different sections of a program. Okay? Different sections of a program. So in a program, we have the body. That will be the statements, the variables, the comments, and so on and so forth. So these two are supposed to be used to enclose that section together. Okay? So this is the body, the program body. Okay? There's a program body. So these will be called opening curly brace. These will be called closing curly brace. So going to the future, writing different programs are maybe more lines than what is presented on the slide there. Then you'll see us enclosing different sections of the program separately for one reason or the other. We'll explain that, especially when we'll be talking about functions. Okay, closing from different section of the programs differently from one point to the other. Okay, so that's a skeleton structure of what a C program will look like. The skeleton structure of what a C program will look like. Any questions as far as the presentation that we've done is concerned? Any question? If you can talk and you have the ability of the audio, well and good. You can type, well and good. Any question as far as what we've presented is concerned? All through from introduction to a sample C program. Any question? No, the developing says that the function from the sample. I've mentioned that we have two functions. This one here, which is the output function for displaying, okay, for displaying output function. This one here is the parent function. It's parent function for a C program. All functions that will be written in any C program will execute courtesy of this function here. Will execute courtesy of this function. Once we learn data types, I'll be able to explain why we have int here. Okay, but for now, just know it's the main function. All other functions written in C program will depend on it for execution. And its purpose is to tell us whether the program executed directly, not directly, executed correctly or not. Okay, if the execution was proper and perfect, 0 errors. If the execution was not perfect, number of errors will be displayed there. Okay. Exactly, Humphrey. The purpose of this sample program is to display hello world to the screen or to whichever display output device you're using. Exactly. Now, this program, this lecture here will be available for you to view, and I'll attach the slides that I'm using here. Okay. I'll attach the slides that I'm using here. You can read them on your own. Then I also can share a whole, what do we call it? A whole module or a whole handout for the whole unit. So I'll share that one as we're going forward, maybe in your emails, so that you can be able to share it out and read it at your own time. Okay. Yes, so this is our primary output function. It's going to be the same in all programs, about 90%, but going into deeper C programming will change, especially when we'll be dealing with files. We'll change printf from the output function and bring on board a new one. But for now, because of the introduction, let's probably say it will remain the same for most programs. It will remain the same for most programs. Yes, so this content will be available on the portal. I'll also attach these notes. You can have a meeting to attend to end the lesson. Get a cup of tea before I can attend to that particular meeting at 10. Okay. Yes, so we'll stop at that particular point. When we meet next, I'll introduce you to how to write programs in a compiler. Then from there, there's a bigger thing that we need to do, design of programs. How do you design your programs? There's a bigger area that we need to do. Although you'll do part of it in system analysis and design, but still we'll have to do it in programming. How do you design your programs? That's where the critical thinking, the creativity is. Are you in a position to design a program for a specific problem? Okay. Once you do that, then converting that program into an application is not going to be a difficult process. Okay. So that one will be quite easy to do. But design of a program is a huge task that you need to really understand well if you are to write programs for what we call the industry 4.0 solutions. Okay, that's upcoming technologies, artificial intelligence, blockchain, and so on. So if you want to write programs to really work with technologies, then the design is very, very important. Okay. Yes. So once again, we can meet next week. Stay safe and read, and read. Okay.